write something, the traditional way of programming or the normal way of programming. Suppose you write some program, okay, and you give some input to that program, uh, input there, some program is there, okay, and that will give you the output. Okay, we will see how this traditional programming is different from the machine learning, why the machine learning came into the existence. Okay, what was the drawback in the traditional programming language? That's basically give birth to machine learning topic. Okay, and after that we will see the deep learning also. So moving to this thing, see, you can see this diagram. This diagram is basically divided into the two parts. The first one is your traditional programming. Okay, the second one is your machine learning. So what happened in the traditional programming? We give the data. That means we give input, okay, and we write some program, we write some code, you can say some set of line we write, okay, that is your code. And what we do, we basically run that thing in computer. Okay, after running that thing in computer, we ultimately give some output. Fine. So this is the one process that we basically follow from our childhood itself when we start learning the programming. Fine. So what is the drawback in this kind of traditional programming? So the major drawback is, suppose you just have given 2 plus 2. Suppose instead of writing 2 plus 2, you just have taken value of A and B as an input from the user and you want to do the sum. Fine. So suppose the value of A is 3, the value of B is 2 and the resultant will be 5. Okay, so what happens in the traditional programming language? These constraints or these kind of variable are fixed in nature. They are fixed. They are not dynamic in nature. Suppose you want to give the addition of the three numbers, a plus b plus c. So what you need to do? You need to go to the program. In the code, you need to change the program. That means these kind of traditional programming, they are not dynamic in nature. Okay, they are not dynamic in nature on input, whatever input you are giving. So this was the major drawback between the traditional programming and the machine learning. But whereas the machine learning is concerned, you give the output, you give the data itself initialize your input. Okay, so what happened on behalf of your input, on behalf of your output, it basically runs in your system and it make one program, and that program is called the pattern in machine learning. Okay, so what happened in machine learning, we give the input, we give the output as a input source. You can consider both are the input, your input and also your output. So it execute in your system, and after executing in the system, it basically form one pattern. Okay, and that pattern is help us to basically deal with the dynamic things, or you can say the dynamic input. So this is the major difference between your traditional programming and your machine learning. That's why the traditional programming was replaceable. It replaced because of the machine learning topic. Any doubt till here? That we have seen what is the difference between the traditional programming and what is the difference between the machine learning. Anyone? You can write in chat also. Okay, I will read it. If you are having any kind of doubt, so you can write, or just write yes, so we can proceed ahead. Okay.
Yeah, as an input, how we are providing data and output as well. Data is okay, but
Sorry.
as an input parameter in machine learning, just think how we are providing data is okay. Data is input data, let us say.
Okay.
Let us say
Okay.
we want to
See.
add 2 plus 2, 2 plus 2 equal to 4. Yeah, 2 plus 3 equal to 5.
Okay.
We are passing 2 and 3 as parameters, and in this we are passing 5 as well. We meant to say.
Yes, yes. We see, just like just take the example of this. Suppose you are passing three to here, three and two over here, and the five over here. Okay. Again, you are passing one over here and four over here, and the resultant will be again five. Okay. Again, you are passing four over here and one over here, the resultant will be five. So what it will basically make up, that the sum of one plus four would make up five, the four plus one will make a 5, the 2 plus 3 will make a 5, or 3 plus 2 will make a 5. Okay, so suppose you have given this value. So it will basically form the pattern. It will basically form the pattern, or it will basically you can say it will form a kind of logic. Okay, by using the machine learning technique. So on behalf of that, it will predict whenever you will give 7 plus 8, what it will do. It will basically give the result 15. So this is the thing. That's why the machine learning is basically dynamic in nature as compared to your traditional programming. Okay. If you're not getting this thing, so we can basically what we can take. Suppose right now we are having two columns. One is IQ, the one is CGPA. Okay, and the last one is yes and no, whether the student is placed or not. Fine. So what happened in this? Suppose the IQ of the particular person is 87 and the CGPA is 8.5 and the student gets placed. Yes. The IQ is 97, CGPA is 6.5, the student is not placed. Okay. IQ is around 81 and 8.1 and the student is placed. Okay. So this will be your input. This will be your input, or you can say this will be your data, and this will be your output. So in the machine learning, we need to basically pass all these two parameters. Okay. So behalf on these two parameters, it will form a pattern. So suppose for the third time you basically pass some other input. So that input could be 83 or it could be 8.3. So it will basically form that pattern. It will we will see how this forms a pattern. Okay, just like a mathematical. It is, you can say it is just, it will just form just like a mathematical model, mathematical method, or you can say the model. Okay. So behalf on that, it will basically predict whether the student is placed or not. So let's assume that it is placed. So it will give you the result, yes. So this is the possibility between your traditional programming as compared to your machine learning.
Okay, we are inputting all sort of possibilities, and based on
Yeah,
that possibility, what is the
exactly.
probability of getting the result? Those input parameters we are providing, it is processing and giving us the output.
Yeah, exactly.
Okay.
अगर कुछ ऐसा खाना हो तो बनाओ, मंगाओ सब्जी। तो फिर कल पर दोपहर में बनाना।
Clear? So shall we proceed further? Okay, so you can take the example of this adding to two numbers. So when you will add two numbers through the traditional method, so what you
ये
need to
बना दो।
do,
वही हम भी सोच रहे थे।
change the code. Okay, when you will take about the machine learning topic, so what it will do, it will basically form the one pattern, and that pattern will predict on behalf of the past data, whatever the past data that you have given. We will see later on how the things will work. Okay, this is something you can say the feature selection process will be done over in this topic. Okay, on behalf of this, it will basically predict whether the student is placed or not, and what will the value of 7 plus 8. That will give you 15. So that is the overall the difference between your traditional and the machine learning. Fine. In the same way, you can see just like the example of a spam email detection. Okay, suppose you are having email. Everyone have the Gmail account. Okay, what happened? Some kind of advertisement come. Yes, some kind of advertisement come, and that advertisement comes with some words, just like some promotion word will be there. Okay, some word just like the free word will be there. Okay, and it may be some discount, suppose some discount word will be there. So what happened when you will use the traditional programming? So what you will do, you will basically write if condition. If you get these words, you get the promotion, or you get the free word, or you get the discount word. So what you will do, you will basically classify that email into the category of spam. So you will say this is email is spam email. Okay, suppose this is two times occurring, this is three times occurring, this is four times occurring. Okay, so in this way you can basically classify this is a spam or not. Suppose what happened, the person who was sending the email, he get to know that you are using this kind of algorithm. Okay, and he basically used some other word. Suppose he uses some other word named extra. So what will happen? Your this algorithm will fail. Okay, this algorithm will fail and will not put your spam your email into the spam category. So for that kind of approach, or you can say what that kind of methodology, we basically use the machine learning technique. Okay, we take the large amount of data, we will have the large amount of data. Okay, and we will train our model, and that model will be able to predict the new things also, just like this extra. If the extra will come up with these words, then certainly it will say your mail is spam in nature. Okay, so this was the one more example by which you can basically differentiate between the traditional programming and your machine learning. Okay, so the same thing, I will share the slide also. Okay, if we will make one I guess WhatsApp group, or I will directly share to sir also, so he will share in your group. Okay, so what happened? The approach, if we talk about the approach, so in the traditional programming, the programmer, we write our explicit instruction that these are hard coded lines. You can say these are hard coded lines, okay, or algorithm to solve the particular problem. But in case of the machine learning, what the system basically, our algorithm basically learn from the data, and it identify the kind of pattern. Okay, that pattern was helpful in basically summing the two numbers or the three numbers or the four numbers, and that pattern was helpful in detecting whether the what we can say our mail is spam or not. Okay, without being explicitly programmed. So this is the approach. That approach we basically differentiate between the traditional and your machine learning. In case of the logic, we can say the logic is fixed. Okay, if we want to change something, we need to go to the code. We need to basically change that thing that was hard coded in nature. But in case of the machine learning, the logic is learned. The machine learn the things from the data one by one, and so on. Fine. Data dependencies. So if we are hard coding this thing, that's mean it is not dependent upon the data, and the machine learning will definitely rely, or you can say it will be dependent upon the data. Okay. In case of the flexibility, this will be not flexible in nature because it is hard coded. It is not dynamic in nature. Okay, it is something you can say static, and this is the dynamic in nature. So it will be flexible in nature. Okay. In case of the accuracy, this will be dependent upon the programmer's logic. What is the logic behind the programmer? What kind of programmer? The logic he is basically making. Okay, what kind of approach he is making, and so on. But in case of the machine learning, the algorithm will certainly depend upon the quality and the quantity of the data. So these two factors are very, very important. So there is one more line. There is line in machine learning. Okay, and that line is garbage in, garbage out. This line is very, very famous for the machine learning model, for the deep learning models also. So whatever kind of data you are giving, same kind of data, same kind of output you will get from that particular model. So if you are giving some garbage value to some model for training purpose, so it will certainly give you the garbage output. So that's quote is very, very famous in ML and the AI field. Okay, garbage in, garbage out. Okay. Again, if we talk about the example, so traditional programming basically it is just like making the calculator or some kind of games. Okay, but if we talk about the machine learning, it helps in the image recognition, it helps in the speech recognition, it helps in the predictive text. What is predictive text? Suppose you are writing something, it gives some suggestion on behalf of your past data. That we will see in the topic of LSTM, long short term memory. Okay, in the deep learning topic. Fine. Any doubt to anyone till here? The
I think,
differentiate. Yeah.
yeah, so just correct me. This is my understanding. Uh, I have a input output, which is a addition of two numbers. I have provided the model, and continuously I have given the sample this addition of two numbers. Later on, this model will only give me prediction for the addition of two numbers.
Can you just repeat? Your voice was not clear, I guess.
Yeah, there is a sample. I have a sample for the addition of two numbers.
Okay, okay. Like,
And I
yeah.
have given the these samples to train this model, machine learning, and this will
Mhm.
only predict addition of two numbers, right?
Yeah, it will. Okay, okay, okay.
It will
You mean to say you have the data set of training only two numbers only,
two
A plus
numbers
B.
only, adding two numbers only, pattern. And in that, it will not give us subtracting two numbers.
Okay,
Uh,
okay.
I have to give this example for this subtracting two numbers again. I have to train again giving this kind of pattern.
So it will not work if you are giving A plus B as a data set. So definitely it will not work on A minus B because it does not know the meaning of this word, or you can say this instruction. So
Okay, so
definitely, yeah, definitely it will not give.
okay, so according to data, it will form the pattern, and it will remember that pattern.
Yeah, we have to basically, because it will what the machine learning model do, it basically find a kind of pattern. So it will certainly look for this one number is there, just like a human, not just like a human. Suppose you are a small child, and the machine learning is also kind of a small child. Okay, you just taught that particular small child A plus B, and you are giving to solve in A minus B, so he will not able to solve this question. That's a very certain thing.
Okay, for that getting A minus B, we have to train
Yeah,
according.
exactly, exactly. We need to give one more data set that would consist of A minus B. The machine learning is just like a small child who does not have any kind of knowledge. So whatever kind of knowledge you will give to the machine learning model or that particular small child, on behalf of that, it will basically predict the thing, classify the thing, or give the result. Same thing, same thing. Yeah,
Okay, okay, thank you.
yeah.
Yeah, Abhinay, one more thing. If we're designing a new machine learning model, so initially we will not have much data, right? Much data set. So how it is usually resolved with in industry, kind of those guys who are making new machine learning models, means how they are testing, checking, and predicting whether this model will work or not without having
Uh,
that amount of.
Okay, see, definitely your machine learning or your deep learning models are dependent upon the data set. There is no doubt on that. If you have a less amount of data, maybe your model will be not that much of accuracy. It will not get that much of accuracy as compared to the people who is having the large amount of data. So this is the thing you can see the differentiate between when you will have the less amount of data and the large amount of data. See, this is something very important I mentioned over here. The quality and the quantity of the data that will define your accuracy. Okay, that's why the deep learning models are much more accurate as compared to your machine learning model. Why? Because they are using large amount of data in nature. Am I clear?
Yeah, okay.
Okay, okay.
But Abhinay, I can supply large amount of data to machine learning also, right? So I
Yeah,
can.
yeah, definitely you can supply. Uh, but the major drawback in the machine learning is when you will give the large amount of data, it will take a lot of time to basically train the model. Okay, and one more thing that I told you in the last class, that the feature extraction will be much more complex for the end user, for you. Suppose you have some domain expertise. So for the large amount of data, you have to extract out the large amount of feature also. So that will be much time taking thing. So that's why people used to prefer the deep learning over the machine learning model. So you can do. There is nothing wrong with that machine learning. You can't pass the large amount of data to the machine learning model. You can definitely do.
Okay, okay.
Yeah. So this was the small difference between your machine learning versus traditional. See, this is the reason why your traditional programming basically was not working in a dynamic condition. That was the main result why the machine learning came into the existence. Okay. So this thing should be very clear. Okay. Again, there are some application. Okay, we will do some case studies over there. We will some solve some code over there. We will make some model. Suppose image recognition model we will make in upcoming classes. Okay, we will make this speech recognition model. Recommendation system you can also make by your own. Okay, we have the fraud detection just like spam and not spam. Okay, So this is something a kind of fraud detection. You can do the predictive maintenance. Means suppose there is some machinery, or you can say there is one pipe. Okay, there is one pipe, and you can say in industry. So what happened? The basically they use the ML technique to basically analyze the outer coating of this pipe, the outer coating this pipe. Okay, and what is the main role of the machine learning model over here? To reduce the cost cutting. Cost cutting. Okay, they want this pipe to be used at the maximum. You can say the maximum. Uh, you can say the maximum limit. You can say the maximum limit or the minimum limit. Okay, the maximum limit when it was very new. The minimum limit when it was at the very last moment, when it was not going to basically overflow something or something. So in the predictive maintenance, it also used the machine learning for maintaining the pipe, such as aircraft part and so on. So in industries also, machine learning plays a very vital role. Okay, it basically analyze the condition of the particular pipe from time to time. So if it degrades something, so behalf on that, it basically give you that okay, about 20 days after it will be broken, so you just replace on the 19th day. So by this method, what you can do, you can basically utilize this pipe in a very good way, and that will be cost cutting in nature. Okay, after that we will see the NLP. After that we will see the autonomous vehicle, self-driving car we are having in world. Okay, so that are the result of the machine learning model, and many of them are the combination of the ML plus deep learning also. Okay, so in this way, after that we have the customer service automation, just like customer support. In this you can basically give the example of sentiment analysis. Okay, so what we are doing right now, the companies are basically recording the call of the customer, as well as the person who is calling to that particular person. On behalf on that, what they are doing, they are basically analyzing the sentiment. Okay, so instead of going through each and every call, what they do, they basically convert the voice into text, and upon that text they do the sentiment analysis. So this is the one more application where we can see the machine learning model. Same thing in the healthcare also, we have the large amount of application detecting the cancer, image analysis, predicting the patient outcome. Okay, and many startups are there in India and also in abroad. What they are doing, they are basically taking the patient. Okay, they are maintaining the patient history. Based upon the patient history, they are giving the recommendation to the particular patient. Okay, so this is one of the use case. After that, I told you in the last class for the stock prediction. Okay, based upon the years of data. So we what we can do, we can basically forecast. So in this, no news is involved. No news is involved because this is not a generative AI based model. Okay, this is something very traditional. It is only using the previous year data. So these are some 10 use cases of the machine learning. Okay, starting with the image, speech, recommendation, fraud, predictive, NLP, autonomous vehicle, customer, healthcare, and stock market prediction. Fine. So we will see these things. Maybe you are having a kind of doubt. So how this will work, how this will go, and so on, so on. So once we will do the different kinds of machine learning model, so then you will get to know key where the speech recognition is working, which model is responsible for the speech recognition, which model is used for the image recognition, and so on. Okay. So this is the one thing. Okay. After that, the very important thing, that why the machine learning model is becoming famous. The same thing, just like the deep learning is having. In the initial days, around in 2010, okay, when the people was starting using smartphones. So what they were doing, they were basically using the smartphone from early morning to the night. So what they were generating, they are generating the large amount of data. Okay, data generation was possible. If the data generation was possible, so what the machine learning model need, they need only the data. Okay, so the data availability become very easy. So from the social media, you can say, from the sensor, from the IoT devices, from the online transaction. Okay, and these data have been used for the machine learning model to get trained. Okay, and the large amount of data, the large amount of accuracy it will achieve. Okay, and by doing the research, we have the improved algorithm from time to time. The researchers are basically working from the very long time, okay, to give the accurate, efficient, and the scalable model, right? After that, we have seen the increased computing power. Before long time back, we all were using the CPUs. Okay, but after you can say in the last 2 to 3 years, okay, in the last 3 years, you have seen the GPUs, the TPUs are also coming, okay, in the market, which are basically used for training the machine learning model, though they are used for gaming also. But for the scientists or the researchers, okay, they are basically used for training the model. So the computing power has also increased very large. Okay, the real world application is also increased. Just like we have seen, these are your real world application. So that thing will also make up the machine learning model uh, very popular. Okay, after that, the personalization. So the personalization, suppose in the entertainment, when we talk about the personalization, so just one word comes in the mind, that is your recommendation. When you see some movie, the behalf of on your previous history, it basically give you the recommendation of the next movie, that this is something related to that particular genre. You can say, suppose you are watching some horror genre, okay, you have watched 1 to 2 movies of the horror genre. So what it will do, it will basically recommend you the third movie from the same genre. So this is moreover related to the personalization concept, where the machine learning model have been used. Okay. Okay. Any doubt till here? Anyone?
Means Netflix and all, they are using personalization. It's based on they are recommending. This is nothing is
Yeah,
also
you can say recommendation is a kind of personalization only.
right.
So, machine learning is all about algorithm, statistic models, mathematics. But
Yeah.
how we can this textual data we can we can trade with the textual data, the words
See,
or
for that, yeah, for the textual data, we do the encoding, okay, one-hot encoding and all those things. We will do the feature selection, feature extraction. So based upon that particular data, when the data get refined for our own purpose, after that we can basically train the model. Okay, and the thing you are talking about, we will see just after 2 to 3 minutes. Okay, how we can basically work with the textual data. Okay, though the machine learning model is, you correctly said, it is statical. Okay, in nature, or you can say it is basically based upon the mathematical approach. Yes. So we will see after some time how we can deal with the textual data. No worry with that.
okay.
Yeah.
I mean, one more thing, in while purchasing Amazon or Flipkart, wherever we purchase something, they usually say people have also purchased. So which model they are using?
So currently they are using deep learning model. Currently they are using different kinds of model they are using. We can't just say that they are using the deep learning model itself, only one kind of algorithm. So what happens, suppose some product is trending in nature. So based upon the other customer history, they also show that particular product. Okay. Based upon your history also, they show some product. So they are using some combined models to give you the some personalization interest. So that thing is you can say that's a different thing, but the basic is the same. The base that they are using, this is the same thing.
Okay.
Yeah. We see before what happened now. Just like you will talk about, you were watching some television. Okay, you were watching some television, and right now you are in, suppose you are in Chennai. So the language of this particular ad was previously, when there was no personalization concept, that's what totally generic in nature. Suppose the ad is shown in Hindi, so it will be Hindi in all over the world. all over the India, you can just assume. Okay. So what happened? The personalization basically started from region to region, from state to state, and so on. Okay. And just like when we use the YouTube, okay, YouTube. So what it basically show? It basically show the ad based upon your own history, whatever you search in some Google or somewhere. Okay. So this kind of personalization has been achieved from time to time, from the generalization to it comes to the personalization. Yes.
Yeah, even the ads which are coming in YouTube and all, it's also I think personalization on them. And similar type of ads are repeating. If you
Yeah,
get
yeah, exactly.
they usually bombard us.
Yes,
Same kind
yes.
of advertising.
Yeah. So shall we move to the next part? Okay. So this is what we have seen in the last class also. Okay. Your AI, machine learning, and your deep learning. So inside the deep learning, your generative AI. So this is your generative AI. Okay. So if somebody says you are learning the machine learning, you can say you are learning the machine learning. If you are learning the deep learning, you can say you are learning the machine learning. Okay. If you are learning the generative AI, you can say you are learning the deep learning. So moreover, all things are correlated with each other or are the subset of each other. Okay. Machine learning is a subset of AI, deep learning is a subset of machine learning, generative AI is a subset of deep learning, right? And
Where
this is,
NLP comes?
sorry,
NLP.
NLP is basically comes in this region, you can say,
So,
natural language
like,
processing. Yeah, mix of this. NLP comes in the mix of this. Your deep learning, your machine learning, and your AI.
okay, so
We will see the NLP also. I have talked to sir also. Okay, so we will cover the NLP also in 15 days. Okay, in the upcoming classes. So first we will finish the machine learning. After that we will finish the deep learning. After that we will finish the generative AI. So once we finish these topics, so these topics are very, very important. After that, what we will do, we will basically finish the NLP in 15 days. So most of the thing you will know previously also. So that will not take that much of time. And mostly we will do the hands-on project also in this, the tokenization and suppose the word suggestion and all kinds of some small miscellaneous project we will do. Okay. So that will make the hands-on practice. So this is the major difference between AI, machine learning, deep learning, generative AI, okay, and NLP. Fine. Now the same thing, you can read these things also. What is AI? It is just a broader field, you can say, of the creating the machine or the system. The machine learning, you can say it is a subset of the AI. The DL is a specialized the subset of the machine learning. Okay, and after that you can write generative AI. It is the subset of DL. Okay, and some kind of example is also given: autonomous robot, NLP expert. Okay, spam recommendation, stock market. When we'll call the DL, it is having image recognition and driving less language translation and voice assistant, just like we have the Siri, Google Assistant, or Alexa. Fine. So these are some the basic difference between your AI, ML, and your deep learning as well as your generative AI. Fine. Okay. Now the thing is that machine learning model, machine learning model. Okay. So what the machine learning model do? Okay. Basically, we will understand first few technical terms. Okay. What does those mean? So few technical terms are, the first one is your classification. Okay, so what does the classification do? One person basically, sorry, I forgot your name. One person asked me, suppose there is some text is written over there. though the machine learning models are statistical in nature, so how basically the text will go and will convert into the number and so on, so on. Okay, that thing we will see in this classification and the regression part. Okay, so first understand what is classification. See, the classification is the task of predicting the categorical label, okay, or the class for a given input based upon the training data. So just take the quick example. Suppose what you were doing, you were having the email, okay? You were having the email, and you were basically classifying it into the two categories. One is spam, and second one is not spam. Okay. In the same way, we have taken one more example. Suppose you want to basically check whether the student is placed or not. So what you were giving? Yes, if it is placed, no, if it is not placed. Okay. So classification means whenever you are categorizing the data into the two parts, that means they should be alphabetical in nature. Your result will be always alphabetical in nature. Yes, no, spam, not spam, cancer, no cancer, spam, not spam, and so on. Okay, so these kinds of classification, this kind of classification is done by the machine learning model itself. Okay, so we are just understanding the term only. We will see what and where it is used. Okay, so this means the classification, and there are some kind of basically logistic regression, decision tree, random forest, SPM, KNN, naive Bayes. These are your some machine learning model which are basically responsible for doing the classification task. Okay, so we will see some of these algorithms. We will do the hands-on practice also. We'll do the code also from a particular data set. Okay. So these are some of your machine learning model which are basically responsible for the classification. Fine. On the other hand, there is one more term. This is known as your regression. Regression means predicting, and whatever the value it will be predicted, it will be always numerical in nature. It will be not textual. This will be textual in nature. Okay, and this thing will be numerical in nature. Suppose one machine learning model is there and it is giving the result in numerical form. It is giving the result in the numerical form. That means it is doing the regression task. That means it is doing the regression task. And suppose the machine learning is model giving the result in the textual form. That means it is doing the classification part. You can say the classification task. Okay, so suppose you have some xyz random model, and that model is giving the result 97.5. So what you can say, what kind of model it is? It is basically a regression model. So on behalf of this two category, you can basically differentiate what kind of algorithm it is. Okay, we will later understand which algorithms come under the classification, why they are coming, which under algorithm come under the class regression, and why they are coming. Fine. So on behalf of these two things, you can basically predict. Okay. Suppose we are having some example predicting the house price, that will be always numerical in nature. Predicting the stock, that will be always numerical in nature. Forecasting the temperature, that will be also numerical in nature. Okay, and some of this, see, it is written over here, continuous numeric value will be always seen as a output in the regression kind of algorithm. Okay, and we are having some example: linear regression, decision, random forest, SPM, and KNN. So these two terms are very, very important because these are the two main things what the machine learning model do. Okay, they either classify the thing or they do basically predict the thing. One more is there, so that we will discuss later on. Okay, so any doubt till here to anyone in classification, in regression? Anyone? Clear to everyone? Can you write yes in the chat so I will get to know and we'll jump to the next slide? Okay, okay, fine. Okay, so suppose you are having one model and that model is XYZ and it is giving the result 95, 97.5. So what kind of model it is? It is your regression model. Okay, suppose there is one more model ABC and it is giving the result yes in nature. So what kind of model it is? It is a classification model. Fine. So this is very, very important. So before moving to the machine learning, we must understand some technical term, the classification and the regression. Okay. Now there is one more thing, supervision. Okay. Why we are reading the supervision? Because our next topic will be the types of machine learning. Okay. So before reading the types of machine learning, we first understand what is supervision and why supervision is important. So we will first go through this line. Supervision is crucial in guiding the model to learn the pattern, this thing, to make the prediction and achieve the high performance. Okay, that's why we are reading the supervision. That's why there are four categories of different machine learning model that will make up the supervision categories. Okay, we will see. So basically, supervision is nothing but it is a kind of observation, or you can say the crucial steps that guide the particular model to learn some pattern, that will make the good prediction and will give the good accuracy. That's it. Okay. So this is something, the supervision. After that, we will see there are kind of four types of supervision you can see. Okay. Four kind of supervision, or you can see the four kind of machine learning model. The both way, you can say both are the same. Okay, the first one is your supervised machine learning, the second one is your unsupervised machine learning, the third is your semi supervised machine learning, the fourth one is your reinforcement learning. Okay, so these are four kind of supervision, what a machine learning, four kind of supervision for ML model. Okay, we will see what is supervised machine learning. Okay, we will see what is unsupervised, semi supervised, and reinforcement learning. Okay, and these are some example we will see later on. After we will jump to the next slide, we will come back to this slide. Okay, so let's understand what is supervised machine learning. Okay, see, the supervised machine learning is a technique, or you can say guiding the model in such a way that you will have the input and you will have the output. How? You will have the input, you will have the output. These two will be the source. Your ML model will be trained, and that will basically form one pattern, or you can say the program. So when you are having the input, when you are having the output, both thing will be there. Okay, and you are making some kind of pattern. So that kind of machine learning technique is known as the supervised machine learning. Okay, this one, the first one, this one. Okay, so this is the quick example. You can say, suppose you are having the data of 5,000 students, and that data basically consists of IQ, your CGPA, your placement, and the placement is in the category of yes or no. Fine. So what we can do, we can basically train one machine learning model over this data. Okay, we will train this machine learning model over this data, and that data will basically form one pattern, this pattern. Okay, and suppose we are giving new values, and your new value will be IQ will be suppose 65, and your CGPA is 7.5. So it will basically generate the new result. It could be yes or it could be no. Okay, so output can be, if it is writing yes or no, so then you can say it is a regression type of a machine learning model. And if it is giving some category result, that means it is a classification type of model. Okay, why category? Because sorry, yeah, this is the regression means
Regression
okay,
is point na numerical.
yeah, numerical. You can say this is your one, this is your one, this is your zero. Okay, just eliminate this thing. Write one, or you can say zero. Fine. Now it's clear.
Yeah.
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 So this thing. Okay. So that's mean what you can conclude from this category, that supervised machine learning model can do both things. It can basically do the regression task also, or it can do the classification task also. this thing, this and this one. So this slide basically consists of the machine learning model. So let's have a quick recap. Input and output will be there. Both will be passed as the input. In the machine learning model, one pattern will be formed. That pattern will help to analyze the result for the new input. Okay, and that result could be your in the numerical form. It is written in the numerical form. That means it will give you the regression result. If it is in the categorical form, that means it will give you the classification result. Fine. So this one. That's why it is having two categories, the regression and classification. Your regression will give you the example, this the example house prediction. In case of classification, medical image. Okay, any kind of image. Okay, suppose the medical image for cancer detection. So what it will give? It will give yes or it will give no. Fine. After that, we will see unsupervised machine learning. So what happen in the unsupervised machine learning? You will have only input. You don't have any kind of output. You will have only input will be over here, and you will have one program, or you can say the pattern. Okay, so this is a unsupervised machine learning. That means you don't have any kind of output. Fine, you will have only input. So that model will not get to know what kind of output I need to generate at the last. Okay, so that kind of model is known as, or that kind of technique is known as unsupervised machine learning. Okay, and we are having basically four types in this. The first one is your clustering, the second one is your dimensionality detection, the third one is the anomaly detection, the fourth one is the association rule. Okay, so we'll understand what is clustering. Okay, suppose what happened, taking the same example. Okay, suppose what happened in the clustering, suppose there are some group of person who are having the IQ greater than 90 plus, so they will come under one category. Okay, suppose there are some other group of people who is having the IQ of 80, so they will come under the other category. When you will have the IQ of people with having the IQ of around 60, so they will form the other category. So clustering means the basically forming a group, these small group. Okay, and this is the basically one application of your unsupervised machine learning. Suppose one more person is coming and is having the IQ of 80, so he will directly go to this category. So in this way, basically it helps to basically predict in which category this person will fall. So this is one kind of application you can say of the unsupervised machine learning. Fine. After that, you will have the dimensionality reduction. So what happened in the dimensionality reduction? So just I have written one example. Okay. Suppose you are having very
You know,
large number.
the first
Sorry.
example for clustering, you said if a new person is there and his IQ is 82, so what sort of patterns we are expecting from this machine learning model? We have
Oh,
three clusters, right? 80, 90, and let us say 60. So these are inputs.
yeah, yeah. These are your input. These are
Right.
your input. Yeah.
So what will be the pattern? Means we don't have output, right?
So if we talk about the pattern, yeah, if we talk about the pattern, so we will use the SPM support vector machine for this categorization, for this type of clustering purpose. So we basically use the SPM. We will see what kind of pattern it is generating. Right now, you can basically see basically what happened when the new person will come. It will basically jump to that category only, which category will reflecting the IQ of 80. So these are your pattern only. These are your, you can say these are your pattern only. This pattern is basically reflecting the IQ greater than 90 plus. This pattern is basically reflecting the IQ of 60. And this category is basically reflecting, or you can say the pattern is reflecting the IQ of 80. So itself, these inputs are basically working a kind of pattern only, because they are already placed in some kind of cluster. Yes.
Okay.
Okay, so this is, you can assume just by looking also now. So these are some kind of pattern itself. Okay, and for this kind of clustering now we use the SPM kind of algorithm, support vector machine.
Mhm.
Okay, so what it basically do, we will see. Basically, it basically divide by using the some plane or the line, these kind of data. Okay. After that, we are having one more dimensionality reduction. What happened in the dimensionality reduction? Suppose you are having the large number of columns. Okay, you are having large amount of columns in your data set, and one column represent your number of room, and one column represent your number of suppose your washroom or something. Okay, so what we can do, we can basically combine these two categories. We can combine these two categories and we can say this is your area. Suppose you are basically, these two categories are defining your area of your home. Suppose your home is having some room and your washroom. Okay, so what you can do, you can basically combine these two categories, and these two categories will be resultant as the area of your home. That means if you are having the n number of columns, okay, and each single column it you can say the representing the different things, okay, and that thing basically have some similarity or the common behavior. So what you can do, you can basically combine them, and that process is known as dimensionality reduction in nature. Okay, so this will comes under the supervised machine learning. So this is also basically what it is doing. It is also forming a kind of pattern, you can say, based upon the input only, just like here. Okay. After that, we are having the anomaly detection. So what it do basically, this is the example. Suppose you are having, suppose one student is there. Okay, one student is there. Okay, he was performing from one class 1 to 10th. He was getting some marks in between. This is your 50, this is your 60. Okay, from 1 to 10th class, he was getting the marks in this category, and certain in the 11th class he gets some 97 marks. So this kind of situation is known as anomaly detection, and that can be basically analyzed with the help of unsupervised machine learning. Okay, unsupervised machine learning technique. So this kind of anomaly is basically detected with the help of unsupervised machine learning. So this is one of the use case of the unsupervised machine learning. The second one is the last one is your association rules learning. Okay, so this is the quick example. So one case study was there. I think this case study was conducted by Walmart. Okay, this I guess it is the parent company of Flipkart. So what happened? There was one in a mall. Okay, in a mall, what happened? There was a list of items. There were large amount of items. Okay, so behalf of on that item, what the people observe that the beer and the diaper, these two things. Okay, these two things, beer plus diaper, when people used to club or they put, the owner of the shop, they put together, so these were the things that were mostly sell. Okay, so that kind of things is known as your association rule learning. That's mean the clubbing of the two or the three items that make the profit. Okay, and that could be achieved through a kind of machine learning model. So that also comes under the category of unsupervised machine learning. Why? Because we are having only input over here, no output. We are having only input, and that input is basically designing a kind of pattern, or you can say a kind of program. Okay, and this kind of, suppose this time 80 times the people are purchasing the milk, and 100 times they are purchasing the bread together. So this kinds of things are known as association rule learning. Okay, so you can see in mall also now. Suppose you visit to mall, so your chocolate, candies, biscuit, chips, kurkure, all those things are basically kept in the front. Okay, and whatever the things which are very essential for you, suppose the rice, wheat, something, they are already kept at the end of the shop. Why they are kept end of the shop? Because the owner of the shop knows that the people will definitely go to purchase these things, But when they will keep these things at the front of the, some people will definitely buy. Suppose you are having a small child, so that child will urge you to basically buy this kind of chips or toffees or the chocolate, etc. Okay, so this types of learning is known as association rule learning. Fine.
In this case, placing of item is also important in addition to association. Like
Sorry.
chocolate, where you are placing your chocolates and where exactly items are placed in shop, that is also important.
Yeah, that is also important. So association rule learning is moreover concerned with the clubbing of the two.
Clubbing of two parameters,
Yeah,
basically.
clubbing of two parameters or the two items. Okay, this is a kind of example that I have given. Okay, so this is something. Suppose here in this item, what you are along with the milk, you just put the bread. Okay, so if the person is coming to buy some milk, so he will definitely, maybe not definitely, out of 10, the 8 people will definitely buy the bread also. So this is something a kind of association rule learning. Okay.
Right.
So on behalf of that, what the shopkeeper or the day they do, so they basically try to put the things in a club way. Okay. So this is the unsupervised machine learning. After
Okay.
that, we have, yes.
Yeah, can you give an example of association rule learning or any like in use case, like an example where it's been applied? Yeah.
Association rule learning where it can be applied practically.
Yeah, yeah, yes.
So this is the example. This is the example. So this is the case study of the Walmart itself. They have observed this thing in one mall. Okay, they have, firstly they have observed based upon the input. After that, they have derived one conclusion that if the shopkeeper or the owner of the particular mall or the shop will keep these two things combined or the club, okay, the sales will go definitely high. That was the learning that they earn from this, or you can say they derive from this kind of input. So that's why this is known as association. Mostly they are used, I guess, in mall or in shops only. And I
Like
don't have,
for product recommendation or something like.
or not, you can say recommendation is not over here. You can't say this is the kind of recommendation, because the recommendation is always done upon your previous history or the previous data. Okay, this is not a kind of recommendation. This is a kind of the learning based result that has been done on the previous data. Or you can say it was I don't know this kind of case study. Okay, but I get to know by reading the things that the beer and the diaper were placed together and that was giving the good sale. I don't know, maybe some the child father maybe came to purchase the diaper, so he basically buys some beers. Maybe this could be the reason. Okay,
Okay.
maybe, yeah.
Well, and mobile cover can be association, right?
Yeah, definitely mobile cover. Suppose mobile cover plus tamper.
Right.
Yes, mobile plus tamper. Okay, and maybe other foods. Suppose you are having some sweets plus namkeen can be also be associated.
Right, right.
Depends upon the person to person. Okay, and suppose the large amount of people are preferring this thing, so this will become a case study, and the other people will follow the same thing.
So
For
I
the
think Zepto is also one of the companies that takes up anomaly detection, if I'm not wrong, given the
uh,
example.
yeah, exactly, yeah.
So kind of like this is like sales optimization for this you can utilize, right, for a business.
Yeah, you can say I have just given the example with respect to the product only. So you can say it is a kind of sales optimization also. So machine
Okay.
learning works in every field, whether it is a sales, it could be your medical, it could be your anything. So this is the kind of unsupervised machine learning used in this sales technique. Okay.
Okay. Yeah. Thanks, Anand.
Okay. So after that, we are having one more time.
One more thing
This,
I wanted to ask, if I can
yeah.
regarding that case where you did for hospital of detecting cancer kind of thing.
Mm-hmm.
Okay. under unsupervised, is it possible that we can, as an input parameter, we can fit, say, X-ray report and other kind of report instead of text and all. Based
Okay,
on
okay.
that, it will detect whether, yeah,
Maybe I guess maybe they can detect because what happened now? What happened? Just a quick thing. Okay, what happened when you experiment something you don't have output? Am I making sense? Yeah,
right,
you don't have any kind of output. Okay, you have only input. So for the initial gona, everyone basically start with the unsupervised machine learning itself. So once they get the output, once they have the input, okay, so they will jump to the supervised machine learning. I hope now it's
okay, okay,
clear.
okay,
Yeah, because what I believe everything, maybe you also think the same thing, because everything start with the unsupervised machine learning. That means it is a kind of experimentation, you can say.
right,
Experimentation, you can say. Yeah. Okay, so moving to this one, okay, because we need to finish this thing also. Because for the deep learning, we are reading machine learning. Okay, no worry. So, okay, starting with the semi supervised machine learning, just take a quick example of Google Photos. Okay, suppose you take the backup of the Google Photos. Okay, your father, your mother face, your brother, your sister face is over here. Okay, so what happened? The Google for the first time it asks you to basically label these face. Suppose you just label as a father, your mother, your sister, and your brother. Okay, this is your first step. On the next row, what the Google do, the basically they categorize your photos. Okay, they categorize your photos. Suppose this is the photo of your father, so they will basically club with this category. If it is the father of your if it is the photo of your mother, so what it will do, it will basically categorize with this thing, will basically place in one place with the name maybe of your mom name or something. Okay, so this kind of learning is known as semi supervised. Why? Because it is supervised in nature. This was the supervised thing, and it was partially unsupervised. This is your partially unsupervised thing. The clubbing of both things basically make the new kind of learning. This is your semi supervised learning, and this is mostly done by the Google Photos. Making sense?
Yes.
Okay, so what do? You do the one-time labeling and do the automatically clustering of the particular photos. Okay, some again one known unknown entity comes, unknown photos come. So again, it will ask you to the label that photo. Okay, so this is your semi-supervised. The last one is your reinforcement learning. Okay, the reinforcement learning is basically based upon the two you can say two parameter, the reward and your penalty. Okay, let's take a quick example. Suppose this is your agent or this is your robot. Okay, so when it have nothing, it does not have any kind of knowledge whether I need to go there, whether I need to go there. Okay, he is something, a child who does not have any kind of knowledge. Just suppose this is a child. Okay, when he go to fire, toward the fire. Okay, so minus 50 point will be detected. Suppose he is having 100 point. Okay, and he know this is the 100 point. 50 will be detected, that will become 50. Okay, so he basically get to know that the 50 points have been detected. That means some penalty will be imposed over it. Okay, suppose he went to the water, okay, he get 50 more point. So that will become 150. This is the one scenario, this is the other scenario. That means he have some rewards. Okay, and this kinds of learning is based upon this is called the reinforcement learning. It is something basically based upon the scenario from the condition to condition, and these kinds of learning are mostly known as, so you can say, condition based learning. And there is a one game developed by the Google itself. Go is the game developed by the Google. Okay, and this game is basically based upon the reinforcement learning over this concept. Yes. So this is something very practical. Okay. Even the chat GPT is also basically using the same scenario to train its model to basically give you the correct result. So how basically they are using the reinforcement learning? If you will give me the 2 minutes, so I can basically tell you. Okay. Some blank slide. Okay. Just give me 1 minute. So we'll tell you how the chat GPT is using reinforcement learning. Anyone who want to tell me how the chat GPT is using reinforcement learning? Anyone? So suppose what happened now? Suppose you do some question to the chat GPT. Okay. You basically give some question and the answer provided by the chat GPT is not correct in nature. It is not correct. So what you do? You again do same question, or maybe this question is not up to the mark. Maybe have some inaccuracy or maybe not correct. Okay, you again give the same question. Okay, and this time you are getting the correct result. Okay, and these things are basically observed by the chat GPT. They are basically observing these things and they are storing your database. Based upon the if some other person asks the same question, so instead of giving this answer they will give this type of answer. Why? Because they have learned the same thing, and this kind of learning is known as the reinforcement learning, and this is the one major factor which is basically responsible in deciding the accuracy of all the large language models, the reinforcement learning. Clear? Any doubt to anyone till here? Okay, so maybe I will share this slide. Okay, so you can basically or what we can do, we can basically make what we can do, we can basically make one group also, so we will do the same thing. Okay, I hope clear to everyone. So please can you write yes, 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 so we can end this. Okay, 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 okay. Okay, fine. So we'll catch up in the next class. Okay. Thank you everyone. Thank you for joining.
Thank you.